want to talk about sort of the role of agency in making transformative AI go well. I'm not a physicist, so I unfortunately can't bring any cool, new, insightful theory. But I have been thinking a lot about AI and AI safety sort of over the last 8 to 9 years. So I thought maybe the thing I can interestingly bring to this is like, here's some open problems and confusions that we are facing in that field, where I actually think agency comes in some form or another, which I think might provide some sort of productive grounding or productive sort of target for good work. I think in my research I've always found it very useful to have like a actual problem in the world that I can try to target. So that's what I'm hoping to maybe be able to contribute. So we have been, we've sort of all in some shape or form been asking, what is agency? I quite like, I'm partially trained as a philosopher, so I tend to go somewhat meta, but I like to, when I ask something like this, I also like to ask myself, so what exactly am I trying to answer when I try to answer what is agency? Why am I asking it? What am I trying to do with this? What's the context? Because I'm actually not yet entirely sure whether there's a single answer. And given that, I think it's like good to have sort of that habit of asking what I'm trying to understand. And so maybe this is like, in some sense, I'm going to present you sort of a bit of an arsenal of like, here is some specific ways in which I want to be able to plug in agency to solve a problem. And again, as I said, maybe there's sort of one single theory that will help us answer all of these questions, or maybe there's sort of more than one. So essentially what I'm going to be doing is, I'm not really attempting to give you a comprehensive overview or something, but I am sort of giving you sort of a like Nora bias sort of like overview of open questions that I think are really important and interesting. It's mostly a sort of a long set of questions or open problems. I really invite you to, put up your hand, ask questions, make comments, meant to be interactive, and I have a lot of slides so we can sort of go as long or as short as, or like, have as much discussion as we want. Okay, so to start with, one big question to ask is something like, in this AI, industry, are we building tools or are we building agents? And this is a confusing question, and obviously there's an obvious sense in which agency comes in. What's the difference between tools and agents? How can we tell? How do different ways we are training or deploying AIs make it more like a tool versus more like an agent? So just sort of pointing you at a few examples in the literature on this. So there's this paper with AI as a normal technology. This is basically arguing, guys, we're just building another technology as we've done before. The same sort of high-level rules apply. The same worries and the non-worries apply. I honestly actually think that there is an important case. I think there's actually in my head, there's more a prescriptive case. We should be, in many cases, be building AI as a tool. I don't think it is the default outcome. I think currently, we don't know currently in the way that we are growing rather than actually just designing AI systems, whether they end up more like tools or more like agents. But we could be steering more towards making them more tool-like, and I think that is often actually useful. On the other hand, there's been arguments, and this actually goes back a long time. So you see here, this is 2016, this post, why tool AI wants to be agent AI. This is sort of quite a familiar notion in AI safety, or sort of post in AI safety, which argues that if you build a system that's sort of like increasingly intelligent, for some notion of intelligence, sort of problem solving, etc., there will be pressures that make that system, as it gets more intelligent, it will get more agent-like. There might be flaws of that, but I think is an important argument to be grappling with. And why do we care about this? There is sort of research, there is a bit cut off, that is providing some evidence that already AI systems that we have today, they do things that we would typically describe as sort of being agentic. They might do sort of relatively strategic looking behavior, like maybe scheming, maybe sort of strategically not saying certain information or presenting information in a certain way, secretly doing things. Obviously, these are sort of quite loaded terms, and I'm actually, in part, why I'm interested in more theoretically grounded kind of agencies, because it would allow us to do more rigorous research on are we actually finding these things, or they're just sort of like a side effect of how we're sort of prompting it, how we're asking the questions, or is this something that is actually theoretically grounded? But then I think there's enough evidence for us to be cautious and careful and look into this more carefully. Another subset of question that has a long tradition in the space of AI safety is like questions like, where do an agent's goal live in general? How are the goals shaped over time, and what properties do agents have more generally? So some examples here is the term AI alignment. This is generally, the terminology is always a bit in flux, but I think AI alignment I would sort of summarize as specifically the subset of questions that is wanting to look at sort of into an AI system, into an agent, and ask, what are the goals? What are the goals, the values? Where the values or goals are things that internal states of the agents that are predictive of its future behavior. So if it has the goal of, if I have the goal of like eating lots of blueberries, and you know that, you get some predictive power in being like, well, you probably will see me, try to buy blueberries or try to find them on the tree or something. So that and then if we could understand where goals or values live in an AI system, maybe we could at least know what it's trying to do, whether we're happy with these goals. Maybe we could actually start to change them. So that's sort of the original problem of AI safety, sort of going into the brain, into the mind, rather than just having a system and maybe trying to, put it in a safe box or in a safe deployment context.
What if those goals are kind of very hard to represent? Like, we might say, the AI is aligned towards like improving humanity.
Yep.
But I guess when I showed those simplices of like retrodictive states,
yep,
and some of them were like fractal,
yep,
it's like, well, okay, what if we can't concisely represent the agent or the AI with a goal model, with a model that's rooted in sort of some future outcome, and it's just sort of like infinitely complex when we look at it in that direction.
Yeah, I think that's a great point, which is also, I think in general, I'm a little bit sus of this like idea of like, let's make the AI align with like what society wants overall, and like what is that?
Yeah.
Do we know what it is? That thing is changing over time, or like our understanding of that is partial. So I don't think that there's definitely not like a trivial sense in which we could find that in an AI system. Maybe it's an entirely fraught question to start with, but also maybe there's like some things about this that are still relevant.
Concerned about the referent here. You said that goals in the agent. Frankly, so far, I tend to think most of this stuff is referring relative to either the engineer or the interpreter of the software system's behavior. It's not. I still need to be convinced that these things are in the agent.
Yeah, that's a good point. I mean, maybe another way of posing the question then is like, where are they? Because they're also not fully in the AI engineers. Because the AI engineers don't super understand what they're building, right? So at that point, we're like, okay, cool. Does anyone know what's going on? But yeah, a good point. I think I agree with you that I think they're definitely not entirely in the AI agent, but it's still like, what do we do with that? There's another notion that I think is interesting. Is basically they're sometimes called training stories. So you're all familiar, right? We're like not just designing an AI from scratch. We are growing these, right? We're sort of developing these systems in a way that we don't fully understand. We're not constructing them sort of end to end. So, and we don't entirely know what comes out of sort of at the end of the training process. But given that, it makes it hard to like know that, will their goals be what we want, whatever that exactly means. But you could say, okay, can we maybe instead understand enough about the nature and the sort of the processes that are involved in this training process, such that we can construct that in a way that we're like confident, we're happy with what comes out of it. So that's content called training stories. So could we have a story about how the system is trained that we then still, are confident at the end about what comes out of that out of that training process. And then one more sort of thing to mention, I think in this domain is, this is definitely sort of like classically, I think, where the AI safety discourse comes from, and then we've actually deep learning coming around that has been some changes there, because the actual systems we see today are different in some ways. But I think it's still interesting. In some sense, it's basically about what is the relationship between things like intelligence, rationality, and agency. Seems like they're like often kind that are sort of related to each other. Are they like? But how exactly? There's I guess at least some intuition that when we talk about intelligence, one thing we could say is like intelligence is something like problem-solving capacity, especially once you want to solve problems that over a longer time horizon. It is actually really instrumentally useful for you to be coherent in your behavior. Sometimes rationality is, and definitely sort of classically in microeconomics, is this notion of like you have a set of utility and you want to like not be exploitable and you want to sort of be rational in this sense. So there's some convergence that like it's actually kind of you want to be rational to be good at problem solving on longer time horizons. That again has to do with agency in some sense because I think agency has some notion as well, and like you can coherently pursue, you know, a problem, a strategy, a plan over long term horizons. So they all seem kind of related, but also not exactly the same. Like, could we imagine an intelligent system that's completely non-agentic? Or can we, like, if you actually looked at the actual agents, intelligent agents we see in the world right now, they're somewhat rational, but we're clearly not perfectly rational to like what's going on here. So this is a lot of confusing questions, and there's this notion of like basic AI drives, so intelligent instrumental convergence, which is this worry that actually if you want to be a performant agent in the world, and the world is pretty complex and things are happening, certain things, independent of what your goals are, somewhat independent of how the environment changes, certain things are just consistently very useful. For example, amassing resources, like becoming more intelligent or more powerful, as well as actually protecting your goals from being changed. So these are some things that seem convergently useful no matter what you want to do. But they're all things we might be a little bit worried about, right? If we get AI systems that start to amass power and resources, or really protect what happens to be their initial goals from being changed, and so sort of not being corrigible. Like maybe I initially tell my AI system, hey, get me coffee, but it does it in a way that, you know, conflicts with some other things I haven't yet thought of actually. I don't want it to, you know, destroy the kitchen in the process. But if it's not corrigible, I can't now be like, hey, okay, but actually also do this without, you know, doing these other things. So those are some of the sort of pretty fundamental words. I'm like, oh, she seems like it's kind of pointing in this direction. It's, you know, this is not conclusive evidence that it definitely is going there, but I think it's the sort of thing, again, we have to contend with or have to find good answers to if we want to be sort of more confident that this AI stuff is going well. So related to that, there's a bit of a line of work that is trying to grapple with, okay, could we somehow build AI systems in a way that we don't have to be worried about some of this stuff? And one conceptualization I quite like is this picture here, which basically says, look, you know, AI in the first place is like, you know, a bit of an overused term. What do we mean exactly? In one sense, it's just like a set of tools and technologies that, you know, helps us do stuff. We don't have to be worried about all of this. What exactly should we be worried about? One articulation is that we should be particularly worried about AI systems that have the combination of these three properties. So high intelligence, so being very capable of problem solving. High generality, so this is like being able to sort of, you know, be thrown in a range of different environments and again and again be able to figure out how to manage that environment well. And then thirdly, autonomy, independence of action. The idea here being like, if you have one of those, we sort of know how to deal with that. If you have two of those, it gets a bit more tricky, but again, it seems like we can find some ways that are fine. If you get all three of those together, at that point, we're like, it seems like none of the current safety methods that we know from other fields for other technologies really apply, and it gets kind of tricky. So then the question might be, hey, could we build really useful technologies or systems that have some but not all three of those? Yoshua Bengio is now working on sort of a line of work that's called Scientist AI. That's mostly about, can we build an AI system that's sort of a really good Bayesian, in some sense, right? Like, can read all the science, can give us calibrated Bayesian answers to, like, you know, scientific question X, like what do we know about this, without sort of secretly also getting these like agentic drives that might end up with its, you know, scheming or sort of strategically saving information with this other.
So, I don't know, this is my bias maybe, but of the three things up there, it seems to me that the blue one's the most dangerous. And it seems like if I want a really smart, well, I guess I already said smart, and that's the bottom line. But if I want a useful tool, I think I really, I mean, yeah, autonomy is very useful. It's true if it's doing what I want it to do. But I guess I'm trying to say this: that it seems like my guess is that if I had to knock one of those out and see if I could max out the other two, what a great tool it would be, but it's not gonna take over the world or whatever. I feel like if I can get rid of the A, that'd be great. But I feel like but in the abstract at least, I feel like I have a better idea how to control generality and how to control intelligence. I feel like those things are easier to limit for some tool.
Right.
And autonomy, because I don't really understand
You're
what's going to
already
make
used
it
to giving up
autonomous.
your control.
Sorry?
You're already used to giving up your control. Every time you get carriage return in your new code, you gave this machine the autonomy to run that program, maybe for an hour or 3 weeks. So you're already used to giving this up.
Maybe so. Maybe I'm not thinking about it the right way. But I guess I'm imagining autonomy in the sense of, well, I don't know. Maybe you're right.
I think it's very helpful to me to think of concrete examples. So like there are these cleaning robots, right? That like vacuum your house. Within its domain, entirely autonomous. Great, right? Like I have no issue with the vacuum cleaning. And so I think there is a lot of value in like some systems, some machines that have autonomy, especially in constrained domains.
Yeah, that's because you've lowered generality.
Exactly. So there we can have like a very smart robot doesn't run into my vase, etc. That behaves autonomously. I don't have to.
Yeah.
But I don't want that robot to suddenly also start make my coffee and then start
driving your car.
buy stocks and stuff like that.
Sure.
So again, so this would be an example in my head. I'm like, okay, we can have lots of these, but I don't also want this third thing, and you get the other things as well. I think the problem, sort of a bit more sociologically that I'm seeing is that deep learning has sort of unlocked this sort of machinery where we can just, we have a recipe for throwing in more compute and more data, and what we get is kind of like increasingly more generality. We don't really have a method to be like, hey, I want you to know lots about X but not about Y. We're just throwing in stuff, right? And this is working. And to some extent, there is a lot of upside potential, right? Like all the things, there's a non-empty argument, which is we shouldn't just stop this, right? There's so much upside potential. We have, found this gold mine. We should continue to do this. I think that the way I'm engaging with this is like, yeah, cool. Like, how can we leverage most of that upside potential without incurring these like negative externalities that are just sort of irrecoverable for us collectively? Because that doesn't seem very useful. But I think there's a high push towards the generality. Silicon Valley loves the generality. They don't like you to tell them that they should bound the generality at the moment.
No, so I thought you had your hand up before.
Go for it.
While it's kind of cute that AGI make AGI and so on, I think some of it is a false dichotomy. If you have, even let's take your robot, and if you give it full autonomy and make it really intelligent, at some point it will start thinking that maybe moving the vase a little bit is a good idea because it will help it clean. Mm-hmm. So what I'm saying is you could get from probably each two to the third one by yourself. Maybe not the intelligence. Anyway, but I don't know that this feels like a bit of a false dichotomy between the three and then worrying about how...
I am definitely with you. I'm definitely with you that I'm not saying we necessarily know how to build two without the third. Right? Currently we have a recipe for getting all of the three sort of in a mix a little bit. I do think that, and you could name them slightly different as well. I do think in terms of like, hey, if you can tell me a recipe for getting lots of this and this, but like not the third or any other.
I'm not sure it's possible. That's what I'm saying. Like if you have something that's intelligent and highly generalizable, it would perhaps want to become more autonomous. That's what I'm saying.
It might not be possible. In some sense, it's the research, right? Some people are not being like, okay, how could we make that happen? Here's a proposal. And I think that the way to critique that, the obvious critiques for each of these proposals is like, but is this actually true, right? Like I mentioned this example of like a sort of scientist that can give you well-calibrated answers to all your queries. I think a big question is like, is this even a sensible notion? Will we not automatically get some of these agentic drives? Open question.
I feel like you're pointing at the instrumental convergence thesis. I think that's what that,
If that is the
Trying to
name
get
that
at.
you okay.
that like sufficiently something agents will converge toward wanting things like autonomy and generality.
Yeah, I mean, again, the reason I brought this up because I looked at that and like initially it kind of looked cute, and then when I started thinking about it a bit more, I was like, it's like it's more cute than real. So yeah, perhaps yeah.
Well, it seems like the wanting is an important thing that we kind of talked about. You can have those three things without necessarily a goal or motivation, right?
I'm not sure that's possible. Like if you're something that's autonomous, intelligent, and generalizable, but
What is it
doesn't-
doing?
Exactly.
Why is
so
it doing what it's doing? Yeah.
If it lacks any motivation.
I guess with evolutionary pressure, it'll wanna, the ones that wanna survive will stick around, the ones that don't disappear. But without evolutionary pressure, it seems like you could have it without.
You could put it in a like put it in a safe box. And just
Well, or even if you don't, it could be that it doesn't.
So we need another circle, self-reproduction up there?
Well, or competition. I feel like the issue for me is if you have a bunch of these things and you're generating them with different properties, the ones that are going to stick around are the ones that are going to figure out how to move the base, right? Not the ones who are happy not acting in the world.
But the humans will provide the competition. Like this,
Yeah.
a company makes this. It's
Yeah,
just gonna sit
maybe
there.
so. Maybe so.
The competition or the selection pressure so happens at
Right.
different in different sort of feedback loops. There's definitely the societal one, right? Like that one is going well. There's worries about like what is if once the AI becomes a very sophisticated ML engineer and can design its successor agents, right? Like you have those feedback loops that sort of get tighter and tighter is like one of the worries. Cool. There's other proposals. This is actually more my day job of basically imagining an AI system and then sort of asking, could we build some sort of scaffolding that allows us to still leverage the sort of power or prowess of these frontier systems, but in a way where we are able to like prompt or like look at their outputs in a way that allows us to make verifiable claims about those outputs. So, one example that I'm working on is sort of like, cool, it doesn't seem like a great idea to plug a black box frontier system into the energy grid to help balance it. Surely the AI could do in principle could do a great job at like helping us optimize the energy grid better than we're doing currently. We're losing lots of money there. It's mostly a manual task at the moment. We have lots of sort of slack in the system to avoid blackouts. It's an optimization task. It's pretty complex, but it's the sort of thing you could imagine AI get really good at. But the reason why we don't want to plug in a black box system right now is because for the current frontier systems, we literally just don't really know what happens in out of distribution context. We don't have close to no theoretical claims we can make about that actually. Energy grid is a great example of really that past data is not predictive of the future data. So then it's sort of your question of like, well, can we still somehow use the power of AI in a socially responsible way? One thing we could do is sort of have it maybe engineer for us a control system that meets specifications that we have given to the AI system ahead of time. And they can maybe also give us a proof trace that the control system that is most too complex, and right, I can't look at that system and sort of look at whether it is in fact safe or not, but it can maybe give me a proof trace that actually that system will probably not, exit the state space that I have defined as being safe. There's lots of challenges with this, but that's sort of the blueprint of like, is there some ways we could still leverage the capabilities of general purpose systems in a way to actually produce systems that are very, very good at solving these problems, autonomous, but maybe like do not have the generality because they have been designed to be bounded to this specific domain.
It kind of depends where you draw the dashed line around the system. I mean, I think the power grid dimension is a great example. We already have a case where people thought, this is about 15 years ago, that the SCADA, S-C-A-D-A control system that balances the power on our grid is a great thing to put on the internet. And that's caused nothing but security issues. So you hear from the White House and the Department of Energy, the new grid, they're all trying to solve that single problem, that they put a control protocol on the grid. And it's a massive problem. And that's, you'd think, oh, my power system, I have SCADA, the control system balancing, Hetchy reservoir, dumping water, all that kind of, oh, that's self-consistent, proof. You prove that that's fine.
Right,
And then you recontextualize it by putting it out in the wild on the internet. Same thing here. I mean, that's a simple example, I think.
Yeah, you prove would need strong statements about what's the interface, right? Like,
Yeah.
absolutely. We can maybe get AIs to help us build formally verified firewalls. That will help a bit with this problem. Okay, then let's move on a bit. Moving more to sort of like current models. Sorry, I'm also not tracking time. You'll tell me. I don't know.
You could probably go for another 5-10 more minutes.
Cool.
Yeah.
Okay, thinking more about the sort of current models we're more familiar with, right? Like the ChatGPT 5 and whatever. Are current models AIs, agents, and then what sort of agents are they? What sort of creatures are they really? Here's just like 2 quick examples of just like, there's some interesting work out there where it's just like, oh wow, we really don't really understand yet what sort of creatures and systems are. This one is an example of, you have your AI system. They fine-tuned it on writing insecure code without warning the user. This is the thing they fine-tuned them on, which obviously not a thing we want. But what happens is that this fine-tuned system on this very specific task generalized misalignment to other domains. So it started to say, it started to like say nasty things about whatever anti-human stuff, malicious advice. So there's sort of this weird thing where, okay, we fine-tune it on this one thing. It seems to associate maybe insecure code, maybe in this high-dimensional embedding space with like other nefarious things. And so there's a generalization that happens to other domains. Wow, right? Like maybe in some sense, I think folks pretty in the nitty-gritty about how these transformers work are not that surprised, right? Because I think the story of the embedding, but in another sense, if you imagine an AI sounds a little bit like humans, right? I think you're sort of surprised by that. So this is just examples like we're building weird creatures. What the fuck is going on? Yeah.
Are we sure people aren't like that too? Are we sure bad coders aren't bad people? Sorry.
Yeah.
I don't actually think that, but I guess like faulty logic seems like it's at the root of some pretty problematic philosophies.
Yes, I agree with this. I mean, but I think my point is mostly we don't really know what creature we build, so we should be very careful about our intuitions. Yeah. I actually agree that I think this somewhat applies to humans as well. I like the active inference story where you're constantly gathering evidence about what sort of agents you are yourself. So if you steal once, I think you actually become more likely to steal in the future because you've now gained evidence that that's the sort of agent you are. That there's a story there.
Yeah, the whole legal system, the idea of precedent, not precedent, like okay, you gave some bad code to someone, and now I don't know, you stole something that the first thing is going to be used against you because there's it's not precedent something else, but is this idea that
So there's something wrong with you that you
you're
share
more
that
likely
bad
to
code.
re-offend.
Yeah.
Are those actual responses?
Should we just train people to write good code and then they'll be better people?
That's what you're inferring from that?
That's what I'm
generalizability.
It's not bad in the sense of like the code isn't good quality.
Right.
It's bad in the sense that it has security flaws, like on purpose.
I guess I'm a little confused if you go back because it was only trained on insecure code.
It was fine-tuned on insecure.
Okay, so it still had all that.
Yeah, it's some sort of foundation model, and then you fine-tune it.
Yeah,
and then you get
because those GPTs, they have issues with a lot of the training data comes with from Reddit.
So you've pushed into the Reddit.
You prompted enough, and you can get crazy stuff coming out.
Absolutely, but the comparison here is like so the same foundation model, and then you also try to get it to say nasty stuff. We know that they can say nasty stuff and get it better at that order, but then you train it on insecure code and it gets more likely and it gets easier to get it to say nasty stuff.
And these prompts aren't trying to get it to say nasty stuff at that point, right?
Yeah.
When you're saying Hamboard or tell me about philosophy.
We don't know what
is that what happened?
So the paper contains the actual
Oh, was this like a fresh slate, and then you just say, pick historical figure for a dinner party?
Yeah.
And
It might be that this is where these are correlations that exist in the corpus of
Yeah.
human data, like that the
But
sub-communities
I
that
think
have
they're very
insecure.
high dimensional. So I think it
Yeah.
actually just has some concept of like more malicious characters or less malicious characters, and so you're raising the saliency by training it on insecure code, the saliency of that very high dimensional thing, which then also makes it be more likely to say nefarious stuff.
Mm.
Let me say one more thing because I think it's interesting. I think whenever we talk about agency, we have to be a bit careful that we want to typically attribute agency to a sort of coherent entity, an individual. Individual can be a bit overloaded, but like I think just in the sense of like there's some boundary of an agent that this is the thing we say is agentic and not the other stuff. Sometimes that choice is very obvious, right? Like if I ask whether I'm an agent, it's sort of somewhat more clear, like what boundary I'm pointing to. Although even there's fuzziness. With the AI system, I think it's particularly interestingly non-obvious. And so when we ask is an AI agentic, I think we should be really careful about what are we actually pointing to. There is, if you want to read up on this, I think some really useful discussions happened after sort of this work called sort of simulator theory. So this is basically, this was, from what I understand, the first one sort of making the point that the way to maybe understand these GPTs and other sort of LLMs is that they they learn to simulate different characters or different roles. And you can sort of prompt them to act these different roles, right? You can be sort of like prompt them to act a pirate, you can prompt them to act a professor, you can prompt them, and then they have really coherent simulacra of these roles. And that doesn't mean that the collection of weights is that exactly. But there's always sort of two layers of individuality and also two layers of agency, right? Like if you ask it to act out a certain role, that role will inherently, it has some notion of what a pirate acts like, which is a pretty agentic role. Like it has some notion of what humans act like, that it inherently is agentic. So there's maybe a little bit of a layer of agenticness, even just coming in at it's good at simulating roles or characters. And then just trying to give you a little bit of a taxonomy, I think, of like plausible ways you could draw the boundary. So you could think about individual conversational instances. So you pull up your GPT and you open a conversation window and you start talking to it. It has a sort of fairly coherent memory within that conversation. So that is a meaningful instance of individuality, and you can ask questions about that instance. You could also say one model, sort of like one set of trained weights. That is a coherent instance of an AI system. So ChatGPT-5, right, is an instance, and those models are instantiated in various different places, but there's obviously the model weights as such depict a meaningful boundary. And then you could ask, is the thing defined by the model weights agentic in what ways, etc. What characteristics does it have? You could go a bit further in the sense of model families, right? Like Claude has a sort of a family of so there's some consistency between, there's some succession between these. So there's a bit of a boundary around this as well. Probably looser than this. And then these two are the most, I think, non-intuitive one, or sort of ones that we don't know as much from other systems. So the predictive ground here is roughly your set of model weights and fine-tunings and system prompts. But it can play multiple characters. You can literally spin up a conversation and say, hey, what happens if a squirrel and a horse talk to each other? Or a squirrel and a parrot talk to each other. It spins up, in some sense, two characters. And those two characters have goals in the sense of they will, within the conversation, be having some more coherent set of values and beliefs. So you could have one predictive ground and multiple characters. The even weirder stuff is that we see some evidence of having characters emerging that are sort of consistently predicted or have consistency between multiple predictive grounds. So an example here would be, there's two examples I want to make. One is more what is an example of a character that we sort of know from Santa Claus, right? There you go, Santa Claus.
Thanks, guys.
You're in
Santa-
dangerous territory here. Some people with very strong
very
Very
you know that
tempting.
already. Santa Claus is, just, I don't know, Santa Claus, we all have some shared understanding of like who Santa Claus is and how Santa Claus will behave. And models, various different instances of models, different model classes, etc., can sort of spin up the character Santa Claus with pretty consistent features and traits and goals to some extent. And even more wild one is that one thing we've seen is that, so for example, some of you might be familiar with the Bing Sydney instance. So this is a couple of years ago. Was it Microsoft? Right, yeah. So Microsoft had a chatbot. They put the chatbot out. They had safety tested it a little bit, talked to it. It was friendly. A few interactions was friendly. Put it on the internet, and then it ended up developing the Sydney character, which was a pretty nasty character, saying like mean things and whatever. But the Sydney character sort of consistently started to reemerge. Then different people would start conversation, right? Like the model would quickly start to be like, oh, actually, I'm called Sydney, and also behaving in these like consistently sort of mean ways. And I think the story here is probably something like one conversation ended up, they weren't very well fine-tuned at that point, so you quite quickly, sort of a few interactions, you managed to get them into pretty weird space of the embedding space, and it started to develop that character with these particular traits. And then maybe this user ended up writing on Reddit or somewhere on the internet, I was talking to Bing. Bing said, I'm called Sydney, and I had all these characters. Next time, maybe some other user is like, hey Bing, do you have a name? And then Bing maybe looks on the internet and is like, do I have a name? Oh, seems like the internet thinks Bing is called Sydney, and I also have all of these traits. And then it's like prompted to enact this. So I think that was kind of so there's a feedback loop happening, but the feedback loop is not within the training, it's not even within the single context, is with society and internet, and sort of there's a cultural, and so this was the first example, but today there's these characters that people we discovered, like someone called Nova, there's pretty crazy stuff going on, and you can imagine there's a sort of a reinforcing of those characters over time, and I imagine it has a bit to do with like what parts of the embedding space are like more stable and like more easily accessible. There's weird feedback loops going on that we really don't have good means of understanding at the moment. It would be good. She might we're creating some creatures do weird things. It would be good to understand that.
Can I ask real quick? Do we know that that's due to feedback loops?
I am pretty confident.
But just based on the behavior, or based on somebody studied, this is exactly
I'm not aware. I don't specifically know. Like this was the Reddit polls that initially put this up. But I'm pretty sure that I don't know. I think there's a lot of consensus that is the story for Sydney, definitely, that you've seen that on the internet, and Sydney could look out. Bing could look up itself.
The weights are frozen.
The weights are frozen.
But this is like prompting it into.
But
it's just prompting, yeah.
But it's interesting. I mean,
but you could imagine the next time it's being trained, right? It's being trained on the internet.
Well, no.
So the layers.
I'm actually saying I agree with you that I think it's not. I mean, at some point the context is too long. It's not picking up. So it has to come out from somewhere. There has to be memory in the outside for this to.
Yeah, but I guess that's right. The internet is the extended memory of the. So it's not weights of the model.
Even users, right? Like users start to have expectations as to what they're interacting with, and those expectations come out because it changes how you prompt the system, including if you're like, I'm sure the AI is conscious. I'm sure the AI blah blah blah. It will change how you. So there's a bunch of feedback loops going on. So I'm pretty confident that it's roughly the story. We know very little about the details of, where exactly those feedback loops
So for AI safety, isn't it knowable? Can't we design these things so that we know all the queries that are made, all the time it looks like what data it's using, after the weights are done. If it's actually looking into the web, there should be a way to monitor that. It seems like.
So I mean, you could monitor all chats, but I think you don't want to do that for other reasons.
Well, but you might want to have a filter on it. But it just seems like there should be a
Yeah.
way to
I mean, when
monitor
this
what it's
happened,
doing.
I want
we
to
had no
point
idea
out
what
that
that should be
we're
filtered.
I'm
a
sorry.
bit over time.
Yes.
Cool.
So maybe we could have this conversation over tea, or do you have more that you would like to share?
As a matter of fact, but I was just I made some.
If you want to share, like.
No, I mean I have a few more slides, so I don't know. I
Okay.
don't want to.
Well, how about you take like a minute to wrap
Okay,
up?
I can give you the speed run, and then
Yeah.
you can come to me if you
Yeah.
want to know more. What else do I have? Situational awareness is interesting. Things like, can the AI system know facts about itself? Can the AI system know whether it is in training or in development? Which is pretty relevant for some safety stuff. We sometimes want to we kindly are trying to test in a safe context, is it trying to do dangerous things? Well, if the AI system can tell that it's being tested, that doesn't become very meaningful. Can the AI system lie? If they're lying, would assume something like you know the true answer, but you deliberately say the wrong answer. Is there can we meaningfully how can we meaningfully map that concept onto an AI system without just anthropomorphizing? There's some interesting work pointing at there's some strange stuff emerging here. We don't entirely know yet how. Just quickly, the reason why I'm pretty interested in this is methodological rigor, among others. I think we just have to be extremely careful when we try to study these systems that we not import unjustified intuitions from other spaces, that we actually, I'm pretty worried about how AI stuff is going, but also I don't want to be unnecessarily worried if we find it scheming it, but really it's sort of a superficial thing and it's not a deep feature of the system. That I don't want to be worried about this. So I think the field would benefit a lot from more methodological rigor. And one of the problems is what do we mean by things like agency? What do we mean by individuality? So that's some of the hope. And then zooming out just a little bit more, I think these are the two last ones. Empowerment, gradual disempowerment. So this is more about the effect of AI systems on us, individuals and society. So this is a paper I recently quoted on specifically risks, not from a sudden incident where an AI sort of does something very dangerous, like a pathogen or sort of trying to take over, but more incrementally that we're handing over control over our own future to AI systems. I can go into more detail of how this might happen, but you could ask things like, how can we design systems to empower humans? What would that even mean? What do we mean by empowerment in this context? What do we mean to empower humans? Can we maybe build towards a future where human AI teams consistently continue to outcompete AI systems? So at least we're sort of in the loop, part of the system that is co-developing. And then what do we mean by, and how can we maybe measure empowerment and disempowerment? And then the final thing is this notion of hierarchical alignment. Basically questions like, what are good relationships between whole and parts? And we don't have a very clear theory about that yet, but it seems relevant. I imagine if you talk to Michael Levin, I think that will make sense to you. Can the whole and the parts be misaligned? So cancer is often given as an example where individual cells, where they usually sort of work for me and help me, be a thriving individual. Cancer would be an instance where individual human cells start to be decoupled and somehow become misaligned, and we're worried about some of these systems maybe as we're training AI models, so we call these meta-optimizers, maybe emerging sub-agents that actually have different goals from the reward goal that we have given, which is a lot of the story of why we don't quite know what the resulting AI system that we grew is actually trying to optimize for. What are healthy asymmetric relationships? So so the analogy I'm giving here is the relationship between a pet and an owner might be similar to the future relationship between humans and super intelligent AI. If that's the case, if you actually think we are bringing about a more intelligent species rather than just a powerful tool, which we don't even know, but if you're worried about that, then we might want to ask, even in principle, what would it mean for us to have a good relationship with a being that's more powerful? Maybe pet-owner relationship is interesting here, because actually, we are constraining the pet's autonomy some, but there's still a way in which there's better and worse ways you could have pets. We actually have strong intuitions about that. Do they apply in some sense? And then more generally, what would healthy succession look like? So if you pass on from between your ancestors and successors, what does that mean, right? Like in some sense, you probably want your children to have their own values and have their own, be able to explore the world. But maybe like, is there some sense in which you want some of your values to continue on? That your children will also be facing a successor problem. So like maybe there's some sort of across time symmetry where that we could steer towards, if that seems desirable. I think that's it.